Okay. Hello. Hello, everyone. Sorry for the delay. Actually, I was on a call. Uh, what the last part that we discussed yesterday? Can anyone tell me? What today? What was the thing that we are expected to start? I must have given you something like what point we'll cover today. What was the last part that we did yesterday? Anyone? Am I audible? Okay. Polynomial regression and feature reduction today. Okay, got it. Okay, so let's cover up the part that we discussed yesterday. Okay, and then we'll start with the next part, right? So yesterday we discussed basics of, yeah, please, Shreyans. Okay, can you explain that on which type of data can you apply linear regression? Does the data set also decides? Yeah, right, it will decide. Actually, I'm not getting the clear picture where to apply which regression. Can you please explain? Okay, look at the very first thing that will affect which regression technique or which particular algorithm you are going to apply is totally depends upon the errors. Okay, like you applied regression, linear regression, you are getting some error. Okay, some mathematical error. You applied polynomial regression and you succeed in optimizing the error better. Okay, means your error get decreased. That means that particular type of, that means polynomial will be a better thing that we can use. First point. Second point, it's like the data also depend, the data, with the help of data also you have to decide which particular regression technique is better, because if data is showing a some sort of linear characteristics means what, it will be like this. Just a minute. It will be like this. Suppose I'm having a data set. Okay, like this. Okay, so this type of data is showing some sort of linearity. Okay, means it will not be completely linear. It can't be complete. If it is completely linear, then we are not required to use any regression technology or something like that. Okay, but it is showing some sort of linearity. Okay, means as the value on x-axis, y also almost increase, so we can go with a linear kind of thing. Okay, so with linear, after doing it, we will, what we will do, we will evaluate the error. Okay, after that we get a particular amount of error value. Okay, thereafter we can apply polynomial regression as well. With polynomial regression, we will get some kind of a polynomial line. It can be any way. Okay, you can suppose you are getting a polynomial line like this. Okay, like this. Okay, some polynomial line you are getting, that is best fit line. Okay, so with polynomial feature you are getting a better result than linear, then you can go with a polynomial. If you are getting a better error, or you can say better accuracy with linear, then you can go with a linear. Okay, so let it be completed all the points, because I have completed the linear part only. I had not finished with the polynomial part. I had not finished with the PCA part. Okay, so once this all things finished up, thereafter you can easily decide which one is better, right? What it's Riyans? It is just the error thing, like error value, which will decide. Or second thing, if you are making, if the data you are having is something showing a feature like this, suppose the data you are having is not so much linear. Okay, it is a feature like this. Okay, it is not so much linear, it's distributed. So in this kind of data, it is very clear that polynomial regression will work better. Okay, if your data is not so much linear, then it is very clear, without calculation also you can say that, okay, in this kind of data, polynomial regression will work better. Okay, so we're going to do the things. Sorry. So what we did yesterday, like you many of you might have the little bit confusion. So you can use what x equal to, again I am just explaining, I'll just finish this thing again. Import numpy h np, x equal to np dot array 4.3 comma, or better make it 3 comma 5 comma 6.5 comma 7 comma. Okay, y is equal to np dot, very quickly I will finish it up. Thereafter second thing will start, 4 comma 6.3 comma 7.4 comma 8.9 comma 9.2. I just transpose it. Okay, thereafter next thing what we have to do, we have to pre-process. That means we need a polynomial feature of all the inputs. Okay, because for polynomial you need a polynomial line, and polynomial line, how we can get a best fit polynomial line? Once we have a coefficients of best fit polynomial line. Okay, a coefficient that can give you the minimum possible error. So to find out the coefficients of polynomial line, what is the equation of polynomial line? All of us know equation of simple polynomial line will be what? Y equal to a plus bx plus cx square, right? It is like this. So it is, you are having coefficients a, b and c. We have to find out a, b or c. Okay, you have a x and s square. So finding out the value a, b and c, that means finding out the coefficients a, b and c, you need what? You need x and x square. X you are having 3, you have to generate 3 square, that is 9, right? To fit the things into this equation and then train your model. Okay, so how can you find it? You can find it by the pre-processing library. What is the pre-processing library? It was from sklearn dot pre-processing, what import, what should I import? I will import from sklearn dot pre-processing import, what was the name? Polynomial features, right? Okay, yeah, polynomial features, right? Thereafter pol is equal to polynomial features, right? I'm not sure if I'm doing any spelling mistake, please verify me. uh degree, degree is equal to 2, right? Thereafter pol dot fit transform, what to transform? Fit transform x. Some error I am getting, I guess I'm doing, that's why I was thinking like I'm doing some error. It was not in 2 dimension, that's why. Now it will work. Okay. So basically what we got the components. We got the components for my polynomial equation. Okay, whatever the polynomial equation I want to make, we got the component for that. Okay, so as we got the component, thereafter we will use this component to train our model. And how we'll train our model? We'll train our model simply using the linear regressions. And in linear regressions, all we know what we use the features to find out the coefficients. So here the feature, these will act as a features for my linear regression. Like what it was TV, radio, newspaper. Three features were there. TV, radio, newspaper. Three features were there. The same way here there are three features. Okay, using this, and these three features basically generated from the single feature only. Okay, there was a single feature, and from that single feature we have generated three features. Why? Because of polynomial equation. Okay, and we have to find out the coefficients for these features. So how we can find out? We can find out by using the what? By using your linear regression. So from sklearn, so people usually get confused also that this is linear regression, but this is not a linear regression. We are using a library of linear regression, right? But we are using what? Polynomial features for that. From sklearn dot what? Linear model import linear regression, right? L model equal to linear regression, right? Then L model dot fit. What to fit? We have to fit this thing, the polynomial feature. Okay, so let's store the polynomial feature in a particular variable, that is x underscore pol. Okay, now pass x pol over here, comma the label. Label is stored in y, so it is get trained. As it gets trained, what we can do? We can make the predictions. How we can make the predictions? We can make the prediction by L model dot predict, right? And we'll make the prediction over only same thing, x pol, and this prediction will be stored in some yp. Okay, now come to the part plotting. Okay, import matplotlib dot pyplot, sorry, matplotlib dot pyplot as plt dot scatter what? X comma y. What is x comma y? Basically x comma y is your this one, real data representation. You are having a real data with some kind of values that is being plotted over x and y, right? The same way you can plot plt dot plot, and you can plot what? X versus the predicted value, that is yp. Okay, so two things are there. First is x and y, and second one is what? Second one is your x and yp. Okay, x and yp means x and the predicted value, and that is the prediction is made over what? The prediction is made through the coefficients given by the training. Okay, so as I plotted it, it is giving me a kind of a line, but obviously this line is not that much perfect. Okay, as the data is very less, so we can expect a more perfect line. Okay, so what we will do in this case? We'll calculate the error. Okay, you know how to calculate error. Error will be what? Y minus yp, right? This is your error, y. I told you earlier also, y minus yp. This is your error. This can be negative and positive. Okay, yp is not defined, just define it. Okay, so to remove all the negative part, what you can do? You can do np dot abs. This is your error. And to calculate the mean of our error, what you can do? You can just use dot mean. This is the mean of all the error, that is 0.20. Okay, now what we will do? We will go back and try to tune the degree. Okay, so just tune it to 3. I tune it to 3. Again I will train the things. Again I will come back and plot. Okay, so something better is happening over here. Again calculate, earlier 0.20, now 0.18. Error decreased. Okay, so what we will do? Again I will try to tune it. So tune it more. You can create an algorithm for that tuning as well, right? Just like gradient descent. So it is tuned more. Okay, now calculate the error. Okay, it is almost 0 to the what? 10 to the power minus 12. You can see E minus 12, so it is almost 10 to the power minus 12 kind of things going on. So it is almost negligible or zero. The error now is almost negligible, or you can say it's zero, right? So that is how you basically work with a polynomial regression. So this is your single feature. Okay, we are having a single feature. What if you have a double feature, x1 and x2? Then all of us know, for multiple features or for multiple variable, the same equation will be converted into like this. In that case, your y will be what? Y is equal to, suppose x1 and x2 are your feature, right? X1 and x2, two features are there, right? Two features. So y equal to what? A plus bx, okay, bx1 plus cx1 plus, right, what, d, okay, wait, just a minute. I will write over here. It is not looking good over there. Y is equal to a coefficient plus b x1 plus c x2 plus d x1 square plus e x1 multiplied by what? X2 plus f x2 square, right? Okay. So this is what, this is a polynomial equation for two variables, two input variables, you can say. This is a polynomial equation for two input variables, right? So in this equation, if I have to create a polynomial regression, okay, for two input variables, what we need? We need these features. That means if 3 is there, then I need what? Like suppose 3 and 2 are two features, then I need what? 1, 3, 2, 3 into 3, 9. And then here it will be 3 into 2, 6. And here it will be 2 into 2, 4. Okay. So these main components will be required for 2-degree equation, right? For 2-degree equation, these main components will be required for 2-degree equation. Who will give these components? The same pre-processing library will give these components, because it is not a good idea to again make a program to calculate these components if library is already present, right? So what you can do, if 2-degree based polynomial regression you are going to use, you have to create this kind of equation. You need this kind of components, okay? And the same way for 3-degree, you need a 3-degree kind of component. For 4-degree, you need a 4-degree kind of component. So what will be the 3-degree? What will be the 4-degree? You can just have your research, a little bit research. Okay, if you find, well and good. If you don't, then you can ask me what will be the 3-degree polynomial equation for two input parameters. What will be the 3-degree polynomial equation for two input parameters? That you can find out. Okay, so based upon that particular equation, this will be the things that you have to calculate, and based upon this thing, coefficient will be calculated. Okay, so see how things will go on. First of all, you need certain value. So just define certain value like this. X is equal to np dot a range 10 dot reshape what? Reshape what? 5 cross 2. That means 5 samples and 2 features. Y is equal to np dot a range, okay, 5 dot reshape 5 cross 1. Okay. So if you want to find out, you can see So these are your features, x1, x2, then y. This will be your y. Okay. So basically what you need to calculate the polynomial feature. How can you calculate the polynomial feature? First of all, you need a polynomial feature, right? So for polynomial feature, you need it. Okay. Just pick these things. Okay. Execute it. So you got the polynomial feature. Let's see the polynomial feature. What are you getting? X of pole. So this is the polynomial feature we are getting. This is higher degree. That's why it is getting too much complicated, difficult to understand. Just make it lower degree. Okay. So for 2 degree, what I am getting? I am getting something like 1, 0, 1. That means why 1, 0, 1? Just a minute. I will explain. Why 1, 0, 1 basically? Because the first two first two feature is 1 and 0. You will see. First two feature is what? 1 and 0. Over here, if I want, if you will see x, this is your x, right? So you can see first two feature is 0 and 1. So based upon 0 and 1, 1, 0, 1, then x square, x into y, y square. That means x2 square. Second feature is what? 2 and 3. 2 and 3 means what? 1, 2 square, 2, 3, 2 square, 2 into 3, 3 square. Okay. Third is 4 and 5. So 1, 4, that means x1, 4, 5 is x2, x1 square, x1 into x2, x2 x square. So basically you have generated the features for that can suit a polynomial equation. You have generated a feature that can suit a polynomial equation for what? For polynomial regression. Okay, that can suit a polynomial equation for 2 inputs. That can suit a polynomial equation for 2 inputs for degree 2. That means what you next want to do, what you got over here, you got over here 1, you got over here x1, this is your x1, right? This is your x2, right? This is your x3, this one is your x4, and this one is your x5. Not, oh sorry, I just I was in a flow, I'm sorry for that. This one is your what? X1 square, this one is your x1 into x2, right? X1 into x2, and this one is what? X2 whole square. X1, x2, x1 whole square. That means using the learnings or using the learning algorithms, you have to find these coefficients a, b, c, d, e, and f. As you can find these coefficients, that means your algorithm is ready for the prediction. As you find out these coefficients, your algorithm is ready for the predictions. Okay. So how can you find these coefficients? Using the same linear regression method, you find the coefficients, and then using the same linear regression method, you just generate the polynomial feature for any feature for which prediction to be made, and then you can make the predictions as well. Okay. So hope image got clear. Okay. I hope that image got clear a little bit. You will get more clarity with the real-time project implementation, real-time dataset by working on real-time dataset. Okay. So what I will do, I will share a real-time data with you. Please work with that data. I will give an assignment to you, and whatever the problem that you face, just ask me, and then we'll solve the problems, right? Okay. So, okay. Just wait. So what you need to do, I will give you a data set. You have to deploy whatever you learned. Okay, the linear regression and polynomial, whatever the points, till the points you learn. Okay, you have to apply that particular learning, linear as well as polynomial, over this data. Okay, just a minute, let me check it. You have to work a lot on this data. There's more sim. Just a minute. Footage street LA. They're built. Which one is extra in it? This is not the thing that I am. Just wait for a minute. I will just give you the better source of data, because in this data you have to work a lot and more time will be consumed. So you can work in this data later on. Okay, after the class, I will give you right now some better data with respect to. Okay, in this data we are having train.csv having a sale price column, right? It is having a sale price column. In test.csv, we don't have sale price column, right? So basically we have to work upon this only. You have to make a model so that we can predict the sale price of a house, right? Just wait. Okay, fine. Just download this data, everyone. I'm giving you the link. I'm giving a link to you. Just download it. Okay, this is my data set. Read the data set over here. House is equal to pd dot read underscore csv train dot csv. Oh, sorry. It should be house, right? House is equals. Okay. So I hope you got it, right? So it would be like house. This is my data, right? This is a complete data I'm having. So what you have to do, you have to make a model. Okay, you have to make a model. In this data you can, first of all, you need to process a lot. Okay, so you can save your time a little bit. Okay, first of all, you can use only those things. I will just suggest you certain things. Just look here. Please don't use all the features. Just use some features that is easier to use, like you can use this lot frontage ms subclass. You can use lot area. Okay, you can use straight. You can, please don't use this la because lot many null values are there. Okay, you can use lot space or something, any things you can use like that. Okay, and thereafter, at last, what you can do, like 1 2 3 4 5, suppose 5 features you are using. Okay, out of 5 features there are a lot many features are there. Okay, so later on you can go with those many features. Okay, but as of now just use 5 features. Okay, air built. Okay, just use only 5 initial features so that you will get an idea. Because feature reduction I didn't told you, right? Oh my god, so many features are there. Okay, so use initial 5 features. Or if you want to use more features, you can use that one also. Okay, that's your up to you. So use the comfortable features and thereafter apply linear as well as the polynomial regression over it. Okay, just apply linear and polynomial regression over it to predict the value of house, that is sale price. Okay, once it is predicted, then calculate the error value in both the case and just tell me in which case the error value is less. Try with it, read the data. If you face any doubt, please ask. Okay, in this data there are too many processings required actually, right? Because there are so many categorical values are there. You have to categorical convert the categorical value into the numerical values, and null values are there. You have to remove null value, delete. You have to analyze which null value to delete, which one to replace. There's so many things you have to do actually, right? So that's why I'm telling you, those parts you can do later on. Like right now, just try your linear regression thing and the polynomial regression thing both. Okay, just so that you can find out the difficulty. Okay, what are the different difficulties that arises out with a data set while we apply linear regression or a polynomial regression. Okay, so those difficulty we can sort out, right? Just complete it. Look here, I had shared a one more link with you. Okay, I had shared one more link with you. That is the, if you can see this link. Wait, I had shared a link with all of you for making the things, for making your task easier actually, right? Those you want to work upon this data, they can work. Okay, otherwise I had shared this link we.tl. I had shared in the chat box, right? You can use this link to download another data set. This is also a housing data, but comparatively more better. Okay, comparatively this two, this is more better. So you can download this one. Okay, and once downloaded, you can access the data now. I will just put it. Okay, so this is what, this is your housing data, right? So instead of using the Kaggle data, the I can use over here housing data. The name is HOUSNG housing underscore data. So you got it, housing data.csv. Right? So this data is comparatively more good, right? So you can access this data also. Okay, if you are thinking like working on that one is quite complex, you can work on this also. Right? So what you have to do, you have to make a predictive model. Okay, you have to make a predictive model that can predict the lot size. Okay, that can predict the lot size. Okay, using certain features. What feature you have to use? You have to use the features like price. You have to use the features like bedrooms, bathrooms, storage, drive away, right? REC room, I don't know what is REC room, you can just find out. So it is REC room, so it's like you have to use these features, okay? Only up to REC room you can use, rest you can just leave, okay? Because in the rest, you again you have to do the categorical, categorical labeling, that is label encoding. Okay, that means yes to 1, no to 0, yes to 1, no to 0. So this thing you have to do continuously, right? So what you can do, you can use up to REC room, you can just convert this thing into categorical value 1 or 0 and just make a model that can predict this value REC lot size. Okay. So the assignment is what? Assignment is like make a predictive model using given housing data. Make a predictive model using given housing data and compare the errors given by linear modeling versus polynomial modeling. This thing you have to do. Make a predictive model using given housing data and compare the errors given by linear modeling versus polynomial modeling. Which one is giving you the best result? Just do it. Okay, see the approach, how to do it. If you're doing it, continue. At the same time, you can see the approach as well, how to continue, right? So this is features and label separation. This one is a feature. In the feature, we are having drive away dot map. Yes, one. So it is mapped up. So we're having this X. Okay. And Y is what? Y is something over here. Okay. Now, how to apply linear regression? All of us know. Okay. So this is what mean absolute error. Okay. This is what your mean absolute error, right? In case of linear regression, right? Now you need to calculate the for polynomial regression. Okay, you have to calculate the error rate for polynomial regression. So how can you do it for polynomial regression? For polynomial regression, first of all, the thing that you need is the polynomial features, right? So it will be like POL equal to polynomial features. Degree you can use 3. I'm using just a degree 3 and we'll check, and then you can again compute, right? So degree is 3. So it will be what? X pol equal to POL dot fit transform. It will fit and transform, but it will fit and transform X. Right? So this will be generated, right? So thereafter, for polynomial regression, I am using LP model. Linear regression. LP model dot fit. Now I'll fit X pol comma Y. Earlier I fitted X comma Y. In case of linear regression, in polynomial regression, we have to fit what? Polynomial features, right? So just fit it. I'm using YPP equal to LP model dot predict X pol, and then Y comma YPP, right? Okay. So here I am getting error around 1169. Okay. So with polynomial regression, the errors that I am getting, the error rate is mean absolute error is 1169 if I am using these many features. Okay. If I am using only 4 or 5 features, how many features I am using? I think 1, 2, 3, 4, 5, 6 features I am using. So with 6 features, this is the error value that I am getting. Okay. I can improvise little bit also. I can make it 4 degree. It's still the same, right? Means it is not like that my error is getting improved. Like I change the degree also, thereafter also I'm getting a same sort of error, right? So basically, now the question, how can I decrease this error value, right? It is increasing actually. With 3 it is at list value. 1169 is the list value. With 2 what I am getting? Okay, with degree 3 the error value is list. So this is my error value 1169, and 1286 is for linear regression. Now the question, how can I decrease this error? Why this error is so big? Okay, the very first reason, we are only using selected features. We are not using all the features. The very first thing, there are lot many features are also there. Okay, if you go into the data set, there are lot many features are also there. Okay, over here you can see till REC room I am using. Okay, but after this REC room, or you can say we have a full base, we have a gas SW, acro, thereafter something called, what was that? preferred area. Okay, preferred area, Gargipel, something it's there. So there are so many features are there, but we are using only selected features, some limited features, so that my this categorical. Otherwise, if I use all the features, then I have to convert this thing into categorical values. That is 0, 1, 2. That's why I'm not using it. You can use it later on. So this is the first region we are getting more error. Okay, this is just the first region. Then what is the next region? The next region, or you can say the main region behind it, is the dataset itself. How dataset itself? Look here. Here in this data set, the biggest challenge, the main problem in the data set is its value. You can see the price value. Price value is quite big. Okay, price value is quite big. The unit, or you can see the magnitude of price value is quite high. Look here. It is in the range of thousands. Okay, 42,000, 38,000 or something. And on the same time, the values related to bedroom, bathroom, storage are very low. Okay, very low means what? These are in single digit, 3, 2, 1, 2, 3, like that. Okay, and you have to predict what? Lot size. Okay, so as you make any kind of model using any kind of algorithm, what will happen? The prediction will be highly influenced by price. Okay, if you consider all other features also, then also the error rate will not improve so much. For example, instead of using all the features, if I am using only price, for example, okay, I will not use anything. Let's see, 1169 is the data that I am getting, error I am getting, right? With polynomial, I am getting 1169. In the X, I will not use anything. I will only use price. Let's see what will happen. I am deleting everything. I am deleting all these things. I will not use these things. Okay, I will use only price, right? If I am using only price, shift plus enter. Okay, so these are not required at all now. Not required. Okay. So only price right now I'm using. I will go down. This is my X now. Okay. This is my Y now. I will go down, and I will use the polynomial features of degree 3 only. Okay, so you can see the difference is not too much. Okay, earlier the error was 1169, that is almost 1200, now 1303. There's only 100, there is a difference of 100. Okay, there is just a difference of the error that you are getting, it is just a difference of 100. Yeah, the value will be bigger, the magnitude of error will be, obviously it is bigger, it will be more. Okay, why? Because it will be definitely more, because the range is in thousands, 5,000, 4,000. So obviously the magnitude will be more, but still it can be optimized more. It can be optimized more using another feature. Suppose I am using 5 feature, the error is 1169 or 1200. Using only price feature, it is 1300. That means the prediction is highly influenced by the price value. Okay, as compared to any other value, it is highly influenced by what? It is highly influenced by the price value, because the value of price is quite high. Okay, so this is the condition that you might face in so many kind of a database. Okay, or in a so many data sets. Okay, so you have to sort out this thing. How will we sort out? We can sort out by what? Standardization. Okay, that means we have to convert all the value in a proper standard range. Okay, if this is your data, all the values should be in a proper standard range. It should be in a proper standard range means what? Like it should be between 1 to 2, 0 to 1, or between 1 to 10. That means we have to, you can say we have to just normalize the value. Okay, that means you have to just decrease the value of price, keeping in mind the ratio should same. Okay, the ratio between price should not change, or the ratio with the other features should not change. In that case, The way the value of price is standardized, we'll convert the price into a standard format, so a standard value. So as standardizing the value of price, we will also standardize the value of bedrooms. We will again standardize the value of bathrooms. We will again standardize the value of storage and other features also. Okay. So once we can standardize, thereafter we can apply what, PCA or principal component analysis. Okay. So just complete up to this point whatever we did till now. Okay, just complete up to this point. After this point we will understand principal component analysis, feature reduction, and a standardization of our data. Shreyans is asking, look, Shreyans, you're too much confused actually. Uh, we applied linear regression in advertising data set, right? Advertising data set we applied, right? So in advertising data set, we were predicting what? We are predicting the sales value, right? And here we are predicting what? We are predicting here, like, if this many features I am having at this much budget, I want 3 bedrooms, I want this many bathroom, I want this many storage, or this many things I want, then what would be the plot area that I am going to get? Here I have to predict, means user will get the plot area, user will get the lot size, like what will be the lot size under certain specification he can get. This is the way, this is the main difference that we are going to do. So that how problem is different from house problem. Can you tell how to solve taking more features and without using linear regression library? Already I told you, right? But it is not a good idea to use without not using the linear regression library. It will be, you know, like whole day will go with the coding only, right? You might be doing some mistakes, right? Because if you, I already told you yesterday only, I told you how to use without using any library also, you have to calculate the coefficients. Okay, so it should work. You might be doing certain mistakes. Why anyway, why you were not using library? Why you were going with that way? That is not, because in a development, when you are developing any program, the knowledge is fine, you should have that knowledge. But when you are going to development and you will say, no, I will not use library, I will directly go in, I will just create everything again from scratch. So that will not be a good thing that will create, right? So if you're having a library, you should work with that. I had shared that thing only for knowledge. Or what I can do, look here, Shriyans, whatever program you are doing, suppose, okay, you are doing without any library or whatever. Okay, the very first thing, the difference, let me tell you, if it can solve your problem. In the advertising data set, we have used what? Advertising data set, right? Data set, right? First, here we are using housing data set. Let me tell you the very first difference. The first difference is the number of features. In advertising data set, we are having 3 features. Here we are having how many features? Here we are having 1, 2, 3, 6 features. Okay. In advertising data set, there is nothing to be categorized. Everything is, the data is already prepared. Here there are so many things, no categorization is required. No category. Okay. No category is there, right? And here we are having a categories, right? Here we are having a categories like what? Drive away. Okay. REC room. This thing. Second thing, in advertising data set also, we did what? We use least square method. Okay. Okay, we use least square method for one feature, just for one feature. If your number of feature increases to 3, then you have to go through that particular gradient descent method. Okay, in that method where we created a kind of a 10 sample matrix. Okay, in that matrix there are 3 features are there, one label was there. Okay, and we were optimizing what? We were optimizing M1, M2 and M3. So just apply the concept. You please don't use least square method over there, or over here, anywhere. If you are having 3 features, 5 features or 6 features. So basically If you don't want to use library, then it will be very complex thing that you have to do, right? You have to define how many slopes or how many uh, coefficients. You have to separately define coefficients for m1, m2, m3, m4, and m5, five coefficients. Okay, and then you have to continuously optimize this coefficient as well, right? That means you have to optimize this like previous. Got it? You have to make it m1 minus m1 equal to m1 minus de upon dm1. Okay, m2 equal to m2 minus de upon dm2, m3 equal to m3 minus de upon m3, m4 equal to m4 minus de upon m4, like that. Okay, thereafter for each case you have to calculate the error. Okay, so that is a very tough, means complex thing that you want to create. So better you should create after the class. Still you get the problem, better you should mail me the that particular thing, because if I will go and solve that particular thing over here in the class, then there are so many important topic will left. Okay, so that's why better you should do that thing after the class. And thereafter, okay, thereafter still if you face problem, I am giving you mail id, you can just put a mail. Okay, I will look into it and try to solve it, right? Okay, so this was the thing, you can just put a mail, I will try it. Okay, next thing, what I was telling, this is about linear regression and polynomial regression. So with linear polynomial, what I was discussing the factor in advertising data set, all the features are in a particular range, same range it was. Okay, so it didn't work so much. But here you can see the value of price is quite high. So the if value of price is quite high, then price will affect your output more as compared to any other feature. Okay, means your output will dependent maximum, it will be biased, towards the price. A little change in price will just change your output, will just change your prediction, no matters other things are what, like it is 3 bedroom, 2 bedroom, 1 bathroom, what others value are there, they will affect the output, but in a very little way, but it's just negligible. Okay, so to sort out this problem, whatever the features you are having, those features should be in a standard range. Okay, and that process is known as what? That process is known as a standardization. Okay, so that thing we will use. Okay, so how will we use this thing? I will explain. I'll explain the PCA part also. Till the time I'm giving you around 15 minutes of break. Okay, those who had completed, well and good. Those who had not completed, they can just finish up to this point. Okay, they can just finish up to this point, right? Just go through all the things, just clear your doubts, how we are proceeding, what we did. Okay, so that you will not face the problems in the next step. Okay, just finish up to this point, everyone. Okay, clear? We'll start back after 15 minutes. Okay. Okay, welcome everyone. So we are going to start the session now. Just 1 minute. Okay. So basically, we have to understand what feature reduction. Okay. We have to understand what feature reduction process, right? What is feature reduction process? The feature reduction process means what? If you are having suppose 1,000 features, right? If I am having 1,000 features, right, and I don't want to use those 1,000 features, I want less number of features. Why I want less number of features? Because 1,000 feature is not suitable for my algorithm or anyway. Okay, it is getting problem for me, or it is getting very tough to create a model with 1,000 features. Okay, because again you have to use those 1,000 features for what? For predictions also. Okay, so if you have 1,000 features, then is it possible to convert those 1,000 features into 10 features? Yeah, it is possible, and that is called feature addiction process, and it is also known as what? PCA, or principal component analysis, right? It is known as PCA, or principal component analysis. Then how it works? It works based upon same sort of concept that you already studied. Okay, let me discuss the concept. Look here. What we do, suppose I am having three features, right? First of all, I am considering what? Only three features, so that you can understand it better. And those three features needs to be converted into two features like that, right? Or one feature like that. Okay. So features will be what? X1, X2, X3. Got it? We are having three features: X1, X2, X3. Okay. So basically, over here, X1 versus X2. I have plotted two things: X1 versus X2, and those features are being can be defined like this. Those features can be defined like this, right? Right. So thereafter, with this feature, what happened? The very first process is to find a line of that will pass through this feature. Then what is the condition of this line? The condition of this line is it should have the minimum variance. Please understand the points very carefully, because it is the same concept that we already studied. The same concept is now extended. Okay, variance should be minimum. What is variance should be minimum? Variance should be minimum means what? Loss should be minimum. Loss should be minimum. Now what is loss actually over here? Loss is this one. From every point, this is a loss, right? This is a loss, right? This is a loss. Okay, this is a loss, right? So this should be minimum. Okay, after this, what you need to do, or what this particular process will do. So this is your first thing, means based upon the minimum loss, line is being generated. Okay, based upon a minimum loss, line is being generated. So again, after this, there will be a perpendicular line over it. There will be a perpendicular line. I will make you understand why a perpendicular line. There will be a perpendicular line over it. Okay. So why this perpendicular line will be used? It is used for the next part, but first you should understand what this particular line is doing. Which line? The first line that we drawn. Okay, the first line that we have drawn, what is this doing? The first line that we have drawn is what is the best fit line, that is having a minimum loss possible. So after this, if we want to consider only one feature instead of two feature, then we have to use the properties of this line or the feature lying over here. The feature lying over here means what? We have to use this thing, this feature. Okay, this will be your new feature. This complete line will act as your new feature. If I'm having just two feature and I want to convert those two feature into a single feature, then this line will act as my new feature, right? This line will act as my new feature, and this is known as what? Variance between x2 and x1. Okay, variance between x2 and x1. Okay, so what you do next, you have to just draw a perpendicular over it. Okay, as you draw a perpendicular over it, what will happen? This will be your new loss. This will be a loss for the, or you can say variance for the perpendicular line just you drawn over it. Okay, the perpendicular line you drawn over it, that line will also have a variance. Okay, so how that variance will be calculated? That variance will be calculated like this. Okay, now the question is why we are doing like this. We are doing like this because we don't know the data is in which format. It is showing a linear behavior, it is showing a non-linear behavior. The data is totally distributed. Okay, the data is totally distributed. That's why what we are doing, we are taking both the conditions. Okay, so that no feature should be left behind. The data will be distributed. So for some feature you can say, or some data, okay, for some x1 x2 behavior value, might possible that this line, the line that we drawn first, will have a minimum variance. Okay, for certain points the line we drawn first will have what? Will have minimum variance, right? This is the first line. And for certain point the line we drawn next, perpendicular line, is known as what? You will have the minimum variance. Okay, so in this case, in that case, all the features will be considered. Okay, all the features will be considered and these lines will act as a new feature. Okay, so what basically is being created using this particular thing? First of all, we do a step that is known as standardization. Standard, we convert the value into a standard format. This is the first step that I explained. Standardization. Okay, second is known as calculating the covariance matrix. Calculating covariance matrix. So what is covariance matrix? This is actually a covariance matrix. What will be the covariance matrix if I'm having three elements? If I'm having three elements, the covariance matrix will look like this way. Look here. The covariance matrix will be of 3 cross 3. How it is 3 cross 3? It will be like this. See, C stands for covariance matrix. X1 comma x1, x1 with respect to x1 means on x axis x1, on y axis x1. C x1 comma x2 मतलब on x axis x1, on y axis x2. C x1 comma x3, that means on x axis x1 and y axis x3, right? Thereafter C x2 comma x1, that means what? The perpendicular line. X2 comma x1 means what? The covariance matrix will have a value cx2 minus x2 comma x1. Cx2 comma x1 is what? Is the property, or you can say is the property of the line that we just drawn perpendicular over x1 x2. Okay. Thereafter C x2 comma x2 means on x and y both axis x2 comma x2. Then we have a C x2 comma x3. Okay. Then we have a C x3 comma x1. Then we have a C x3 comma x2. Then we have a C x3 comma x3. Okay. So this is known as covariance matrix. Covariance matrix means what? A matrix that will represents the variance of all the elements. The variance means what? Error. Okay, error value or loss of all the lines. That means if you had, suppose you are considering this one, cx1 comma x2, what will be there? So what is cx1 comma x2? Cx1 comma x2 will represent the variance, will represent the loss. Okay, if or will represent the feature of this line. Which line? The line you drawn first. Okay, the line you drawn first, this one. This is cx1 comma this, the feature of this line, because this line is having what? This line is having the minimum variance. Okay, this line is having the minimum variance. Minimum variance is minimum loss. Okay, so this is what will represent the first feature, you can say. Okay, so whatever the points that are basically over this, that will be considered as a single feature. Okay, so instead of using x1 and x2, now single feature will be considered, and that what will be the single feature? The feature of this line at each point. Okay, that means instead of using this point, okay, in this point there are certain x1 and x2 is there. Okay, x1 and x2 is there. So if you draw it perpendicularly, now new feature will be what? This one. Okay, whatever the value of x1 and x2 is there, but this line will give you a single value, and that value will be your new feature. Okay, so it is x1 comma x2. And what is x2 comma x1? See x2 comma x1, the perpendicular line that is drawn over here, that is x2 comma x1, right? So if you are having a 10 features, then 10 cross 10 covariance matrix will be created, and based upon that covariance matrix, based upon that errors values and all, whatever the errors values are there, whatever the variance values are there, based upon those value, we basically calculate the feature with least possible variance or least possible error. Okay, we just consider the feature. Suppose I have to consider 3 feature only. Okay, I have to consider 3 feature only. Okay, so I will consider the 3 feature with least possible variance. So what would be those 3 feature? Those 3 feature will be actually some linear line only. Okay, will be some linear line only, but those line will have the least possible variance or least possible differences from the actual value. Okay, and this is called feature reduction. If I have to consider 2 feature, then I will pick only 2 feature which is having the least possible variance. Okay, so this all process is known as principal component analysis, right? So how this process will continue? This process will continue with the very first step, that is called standardization. Okay, so what is basically standardization? So better you should implement it, then you can understand what is standardization. Okay, so before implementation, Just a minute. Uh, just wait. You can note it down somewhere because I'm just removing it, right? So because you have to code over here. Okay. Right now I'm removing it, then I will just code, and after coding, again I will explain as per the coding. As the code runs, I will again explain with the codes, right? So we'll get a more concrete concept, right? Okay. So look here. First of all, we need a data, right? We need the data. So just we'll pick a data. We'll pick a data. You have to use housing data. That will be assignment for you. I'm picking some data, okay, from sklearn dot datasets import load breast cancer. Okay. This is a data of breast cancer. Okay. This data is representing two things, two types of tumor, and those tumor size. Okay. So let's see. Cancer equal to load BREST breast cancer. This is a data that is already available in scikit-learn. Okay, scikit-learn is having this data, right? Now pick the data set. As you call the data, you can see certain things. You can see certain things. The very first thing you can see, the data is not usual. Okay, it is not like the data that we had already used. It is something different. Okay, the data is like in a JSON format data. Okay, it is not CSV kind of data. It is in a JSON format of data. That is called a dictionary form of data. Okay, we are having what? We are having keys. We are having keys like this, right? We are having keys available, and then with the keys we are having what? Values available. Right? Values are already connected with the keys. Right? So basically the data is a JSON format of data, or you can say dictionary format of data. So what you can do, you can first pick all the keys. What are the keys available, so that you can understand it better. Just pick up the keys. So these are the keys I am having. That means data that might be containing the features, then target that might be containing the target value 0 1 2 like that, then target names, then description, then feature name, what are the features basically, and then file name. Okay, if you want to know about more about the data, then what you can do, you can just pick cancer and description, right? This is a description you are having. Okay, it is not showing proper. You can use the print as well. So just get the description, all of you, then I will explain after this point. Just be ready with this point. Complete up to this point, then I'll explain. Okay. So this is your description. In the description, you can see certain things like what is about data and all. Okay. And here you'll see there are two class. Okay. Malignant and benign. Basically, there are two types of tumor over here. Okay. For a person, like if it is a cancer, then two types of cancer tumor might be there. One is malignant, and second one is benign. Okay. So you can just use these things. Okay. We have to use these things as a label. Okay. But first we need a proper data, right? So we can pick a data from where? We can pick a data from cancer. This is your thing, cancer data. Okay. This is one of the key, right? This key is having a data. This data is looking quite abnormal. Okay, it is looking quite abnormal. Okay, why it is looking quite abnormal? Because it is not properly arranged. So what you will do, you have to properly arrange it. Okay, so how can we arrange it? We can arrange it by forming a data frame. Okay, so let's form a data frame. DS stands for data set equal to PD dot data frame, and pass this thing called DS. Okay, so this is a data frame now we are having. In this data frame, there are so many features are there. How many features are there? We are having 30 features. That's a huge number, right? 30 columns means 30 features. That's a huge number actually. So basically, cancer data is there, and we have 30 features. Okay, but in the column header we are having 012, right? So 012 is not looking good. We what in place of 012, what we can use? We can use actually the feature names, as feature names are also present. Where is feature name present? The feature name is present in a column named feature names only, I guess. Feature underscore names. It is present over here. Feature names are present over here only. You can see these are the features name, right? So the total 30 features are there. You can use this as a feature name. Just you can copy it. Control X. This is your feature name, right? So you can assign a feature name like this. COLUMNS columns is equal to. Okay. So now you are having a data ready. Now you're having a data ready. Mean radius, mean texture, mean perimeter, mean area, mean smoothness, everything is there. Okay. This is your features total. How many features are there? You can just see. And where is the target? Target was there in target only, right? So target will be required later on because we don't need target, right? For feature engineering or for feature reduction, the target is not required at all. We have to only work upon features, right? So feature is important for us. So just pick these things. DS dot head, right? So once it is done, second process is known as your what? Standardization. Okay. So what basically is standardization? Standardization means you can see the values over here. It is in the range 17.99. It is in the range 10.38. It is in the range 122. This is 1000. Then again all of a sudden drop down. This is drop down. This is below zero. This is below zero. So basically what does standardization do? It will just convert all the value in a particular range that will be between 0 to 1, or it depends how you are using. Like you are using normalization, or you are using like a standard or it is standard deviation. Okay, so it depends upon you need. For example, if you are using a standard deviation kind of a thing, then what basically you have to use? You have to use a formula. The formula is like this. see here, this is something will be, this kind of things will be considered. Okay, so how it is going to be used? It will be like, each value will be affected by a particular formula. Some of you might be knowing this formula as well. Xi minus mu. What is mu? Mu is your mean value, average value, right? And this one is your what? Standard deviation. Okay, this one be your standard deviation, means xi means actual value minus mu. Minus mu means what? It will be your average value. Okay, and then standard deviation divided by standard deviation. Okay, so this is called what? This is called, this formula will be used by pre-processing library, just like we use sklearn pre-processing import what? Import polynomial features. The same way we will use a pre-processing library that will just convert the value into the standard format, and that format it will use a standardization formula, that is xi minus mu upon what? Standard deviation. Okay, so using this thing, it will be converted into a standard formats. Okay, we want to see, you can see by just import the library first. The library is what? From sklearn dot pre-processing, that is a pre-processing library. Import a standard scalar, standard standard scalar. Okay, it is imported, right? Give it object scalar is equal to standard scalar. Okay, and thereafter just fit the data scalar scalar dot fit. What fit will do? Fit will calculate those parameters. Which parameter? The mean value and the standard deviation over what? Over ds. Okay, so scalar dot fit what? Ds. Okay, you operate it. As you operate, you will get the parameters. Okay, it is showing some error. Let's see. What it is showing from sklearn dot pre-processing import a standard scalar. Why it is showing error? Just a minute, it is showing error. Let me check. Sklearn dot pre-processing. Am I doing some mistakes or what? Yeah. Scalar spelling I'm doing now. Just a minute. Sklearn dot pre-processing import standard scalar SCL equal to standard stnd. Just I will copy it and I will paste over here. Okay, scl dot fit ds. Done. So with mean is calculated. With what it is showing? Copy true. With mean, that means mean is there. With std means standard deviation is also there. So you can use those parameter by using fit transform. Okay, so you can use scl dot transform, directly scl dot transform what? Ds, right? So either you can use fit transform together, just like previously we used fit transform together. Okay, or you can use what? Fit once, and means with the fit the values will be calculated, like mean, standard deviation, and all those things will be calculated whatever required, and then you can use transform, then it will transform the things. TRN is transform the thing. Okay, so you can use what? Scaled underscore data equal to this one, SCALED, scaled underscore data. Okay. So scale data is there, but still we can't see a proper thing. It is showing very kind of abnormal. So how can you get get the proper data? You can use pd dot data frame as you pass pd dot data frame, you're getting something like this. So now you can see the change. Okay, the data which was the data which was not so, which was having such a huge range, has been converted into a lower range value, and without affecting the others ratio. Okay, that means the ratio will remain same, the difference ratios are same. Okay, the changes are same, only the values decreased. Okay, so this is called a standardization of a data using the standard deviations techniques, right? So once you standardize the data, the only thing you have to do, you have to call the PCA library, and with PCA library you can directly scale it, right? So how to do next? Just call a PCA library from sklearn dot decomposition import PCA. Okay. Thereafter define PCA, the object of PCA equal to PCA. Okay. Now how many components you want? There are 30 features. So how many components you want? You want to convert 30 features into, suppose, 2 features. So just define and components equal to 2. Okay. And then PCA dot fit scaled data. That's it. It will just fit the thing. Okay. Right. So thereafter it is done. It just fit the thing. Now after fitting, you got the number of components 2. Now those components you want to transform, okay, to visualize. So what you can do, you can use xpca equal to pca dot transform. PCA dot transform what do you want to transform? Scale data, right? So you can see earlier you were having how many features? Earlier you were having 30 features. Okay, now you are having what? Only 2 features. So our feature is reduced, the dimension is reduced, that is dimension reduction is done. That means if you consider a scaled data dot shape, this is having how many features? Total 30 features are there. Okay, and xpca dot shape, this is having how many features? 2 features. Sample size is same. Okay, sample size is same, but the feature is reduced. Okay, now as the feature is reduced, then there might be a query that we lose something, because 30 features is having certain information. Okay, and if 30 feature is reduced into a 2 feature, then we can think that there must be certain information we lose. Okay, there must be certain information that we are losing, right? There might be certain loss of information. So that thing also we can verify. Okay, are we losing some sort of information or not? Okay, So for example, I will show you, are we losing some sort of information or not? How can we verify? The easiest way to verify anything is plot over x and y axis. Right? So what will we do? We will just make a plt import mat plotlib.py.plot.plt, right? Thereafter, our data is in xpca, right? I will consider x1 is equal to xpca, use the concept of slicing, and I will consider what? I will consider the first column, sorry, yeah, first column, that is 0. And x2 is equal to xpca, and I will consider what? Second column, right? You can see cancel target. Target was one of the key. On a target, how many targets we are having? We are having only two targets, that is 0 and 1. Okay, we are having only two targets, that is 0 and 1. So how it is going to be used, I will make you understand. Plt dot scatter x1 comma x2 comma color. Color is what? For color we can give C. Okay, so C is equal to, I will directly pass this target. So all the value, like first feature, if first feature is 0, that will be plotted in a particular color. All the features with 0 will be plotted in a particular color, and all the feature with target 1 will be plotted in another color. Again I am repeating, all the feature with target 0 will be plotted in one color, all the feature with target 1 will be plotted in another color. Okay, thereafter plt dot x label first principal component. This will have a first principal component. Plt dot y label, this will have second principal component. Thereafter plt dot, so you can see that we have reduced 30 features into 2 features. Still you can see we are having two types of component over here. There are two types of labels over here. One is 0, one is 1. That means there are two types of features over here. Total features are basically of two types. One is tumor 1, another is tumor 2. Okay, so basically, and these tumors are basically what you can do. There is a proper division that can be created between these two tumors. Okay, that means whatever the algorithm you want to use, you can use knn, decision tree classifier, svm, random forest, xgboost, whatever the algorithm you want to use, you can use. It will always give you the best result, or you can say best accuracy. The accuracy will always be above 90%, because no information is lost. In spite of losing the information, your data get more, you can say, more accuracy friendly. Okay, your data gets more accuracy friendly means now you can process faster. Okay, you can process faster and you can get a more better result, more better accuracy you can get. Okay, so through a standardization and through PCA you can enhance your model performance as well. Okay, so just complete the things, every point, and just try to apply the same logic over housing data and see, is it possible to increase the accuracy in housing data as well or not. Okay, in housing data also please apply it and just check, is it possible, because again I am telling you, with the 30 features over here, you know, it will be very complex to create an algorithm, means to apply an algorithm. That will be a quite, like if you apply knn, then it will take so much time, you know. With a knn it will calculate 30 distances and then compare those distances, then it will take a year to do the things, right? for creating any kind of model, it will be very tough. So basically, what is PCA? Is PCA is algorithm? No, PCA is not algorithm. Okay, PCA is not algorithm. PCA is a unsupervised learning technique. It's a unsupervised learning process. Okay, it is totally a unsupervised learning process. As in this process, we are not using any label. We had worked only with the features. So this is totally unsupervised learning process. Okay, in that process, you just consider the most efficient features with a minimum loss or with a minimum variance. Okay, so once we consider that thing, thereafter we will use that feature for the predictions. You can consider 2 feature, you can consider 3 feature, you can consider 4 feature, it depends upon you. But as of now, I am considering only 2 features. Suppose with 2 feature, that means the feature 1 x1 is that feature from that line which is having the least variance. X2 is second most, you can say, second thing, or you can say second feature that is having a least variance. Okay, x1 is having the least error possible, means least, you can say, difference from the actual data. X1 is that feature which is having a least difference from the actual data. Next 2 is that feature which is having a next least possible. X3 next least, X4 next least, and that's how it will continue. Okay, so it is just a PCA. If anyone asks you, or anyone, is PCA is algorithm? No, PCA is not algorithm. PCA is basically a unsupervised learning process through which we just calculate the most significant feature out of n number of feature by using the steps such as standardization, and then calculating the covariance matrix. And after covariance matrix, based upon covariance matrix, we just pick the most significant features that can be used for your predictions. So complete this thing, all of you, and after completing it, please apply over housing data as well. Yeah, sharing. Tomorrow I will discuss more about unsupervised learning. Okay, more unsupervised learning techniques we will discuss. Okay, so some more concepts will get cleared out. Okay, so this is just a first, you can say, a first image of unsupervised learning. Are you working over it? Are you facing any problem? You can ask, right? What happens, Shreyans? Why you could not convert? What you asking? Just a minute. Okay, what problem? Could not convert a string to float. Yes. Do you need to assign 0 or 1? You're right, you have to assign, right? Without assigning, how can you work with? Because no algorithm can treat any string value. Okay. Algorithms can only work upon with mathematical values, right? So you have to convert a string value into a mathematical terms, and then you have to use those things for your algorithm. All of you, please be ready with that thing, Anaconda or any other software, offline software, whatever offline software is suitable for you. Please be ready with a particular offline sort of software. Right. Next thing, I'm giving you a link. I will prefer Anaconda because through that I can I will let you know about the computer vision technique. Most probably the tomorrow class or day after tomorrow class will cover a computer vision technique. After unsupervised learning, we'll cover computer vision with computer vision only. Uh, I will let you perform certain tasks like certain more algorithm like descent tree classifier, random forest, and SVM and other algorithms. Okay, so for computer vision we will use images and all, so that's why offline programming will be required. So please do install Anaconda version, the version that I discussed with you. Okay, and as well as download something that I will just a drive link I will give. Okay, from that drive link just download a library. Just wait. How to import any CSV file, XLS file in Anaconda is a syntax. Yeah, it is similar to Colab, Aditya. You have to use the same thing. Only over there you have to pass the complete location. Okay, like complete location means what? Like pd.read CSV, and thereafter you have to pass a location like if it is in a C drive or D drive. So if you write D colon folder name, sorry D slash folder name slash the file name, like that. You have to pass the complete location, Aditya. Yeah, that is okay. That is okay. Any ID you can use. It's not thing. You can use a spider or whatever. The only thing is like you should have those packages like NumPy uh, and what was the pandas, matplotlib. Okay, right, Parthiv. These packages are there in your system, Parthiv. Yeah, so then you can just only one more package we will require, that is OpenCV. Okay, so we will install the OpenCV. I will tell you how to install it. Is just like pip install OpenCV or conda install OpenCV, or if you want to search, you can also search and can now install it. Okay, and after installing, just like if it is OpenCV installed in your system, if you can install, well and good. If you can't, then nothing to worry. I will tell you how to install. And after installing, how can you check that it is installed or not? You can check by import CV2. Right? Just like import pandas, import numpy, import CV2 will execute if it is there. Okay, if it is not there, it will not execute. Why am I telling you offline mode? Because we are going to, if we use images, right? So images will contain a huge data value, right? So working online will be a kind of a big problem for us. So better work offline with heavy data value. I have shared this drive link. Okay, there is a library in this drive, right? All of you please download. So suppose if in future something is not working properly in your system because of I will recommend that antivirus should not be there. Okay, because antivirus generally deletes some files. Okay, so suppose if something is not working properly in your system, or some errors or something, some problems are there, then this is a library that you can directly use. This is a complete package that you can directly use. Okay, and using this package will let your job done very easily. Okay, so this is one of the things. Means no download is required, directly you can just download and extract it. Later on I will tell you what to do, right? So today you have to just finish the task. Is there anyone who finished? How much error are you getting with this particular thing? Is there any error improved on housing data? Yep. Okay, great. But Shreyans, after reduction, what we need to do? Which reduction? You just reduce the feature, right? So after reduction, what will you do? Yeah, right. So after reduction, you will just like you just make two features, two best possible feature. So you will apply both the things, linear regression and that polynomial regression, and try to find out the errors value, like how, because you have reduced the features, you have not made, you didn't made any change in the labels, right? Because we can't make any change in the label should be as it is, right? So now just make the predictions using both the algorithms, linear regression and polynomial regression, and just check is the error value, whatever the magnitude of error that we were getting earlier around 1146, 1169 or 1200, So is that magnitude improved or not improved? This thing you have to verify, Sirans. Right? Right, right, Shreyans. Absolutely right. Whatever you were telling, the same thing, that means the dimensionality reduction. This is what dimensionality reduction means. Okay, means consider the most significant features out of all the features. Consider the most significant feature, and that also means you can say in a reduced dimensions. Okay. Okay, Akhila, what you got? How many dimensions you are using as of now? You reduced the dimensions, right? Okay, you are using 2 dimensions, right? So you are getting a around 1395. By what? By this thing, linear regression or polynomial regression? Okay, through linear you are getting this thing, and and by using polynomial. And one more thing, Akila, just tell me, before reducing the dimensions, how many dimensions you considered for reducing? How many dimensions you considered for reducing it? Total, how many dimensions you considered for reducing? No, no. 2 is the reduced dimension. Okay. Before reducing, how many dimensions you considered? Like five dimensions you considered, six considered, seven considered, or eight, 10? How many considered? Like this is your housing data. Where is it? This one is your housing data, right? Okay. In this housing data, no, not this one, not this one. Sorry. Where is it? Okay. This one is housing data. In this housing data, actually, it is, yeah, right. 13 for Shreyans used 13. Akhila is using 1, 2, 3, 6. Okay. So with 6, you are getting that kind of thing. Okay. So let's give a figure. Shreyans, what figure are you getting? No, no, that is okay. 546 cross 2, that is okay. I'm telling what error figure are you getting? Okay, you can calculate. Okay, do one thing. Consider the maximum features possible, right? Because the output is dependent upon the features. Almost you will get at least the error value will get in a 3 digit, right? 3 digit error is something that you might get. Okay, not 4 digit, 3 digit. It can be improved up to 3 digit, and it might possible that we can improve it up to 2 digit, but ultimately it will improve. Okay, so if suppose still it is not improving, okay, suppose if it is not, so you can apply certain things. Just let me give you some insights. What are the different options? Because doing a machine learning programming is like trying on different things. There are a lot many things we have to try. It's kind of a hit and trial because we don't sure like which things will work upon. Okay, so first thing, please do try after just standardization without any kind of a feature reduction. Okay, just do a standardization. Just convert the data in the standard format. Use directly 13 features. Okay, you are having 13 features. So in 13 features, okay, you can directly use a standardization, and after standardization you can use those features as a feature X and then Y as a label. Okay. Second option, or and compare this thing with second thing. Again, make the predictions after PCA and use at least 3 or 4 reduced feature. Okay, use at least 3 or 4 reduced feature. Okay, not to use with at least 3 or 4 reduced feature. Okay, so first do the standardization and do the things, means after standardization only directly apply, means you did standardization and directly apply the regression technique. There can be some error, then after doing the PCA then again apply the techniques, then again you will get certain error. So this way we can get a image like after PCA my model is improving, or after standardization only it is giving me a better result. Okay, so this is how we can, if after standard, because same rule we can't apply everywhere. Okay, so if after standardization it is giving me better result, okay, that means by applying PCA we are losing something, right? That means by applying PCA we are losing something. But if it is not giving me after PCA it is giving me better result, that means that is a better option that we can choose through. That means we can go with the PCA. Okay, you are getting 1316. Okay, that's nice. And you are getting 3095. So 1316 Shreyans you are getting through polynomial, right? Okay, through linear. So you can try with the polynomial also. I will also solve this problem and let's see what best possible things that we can achieve. Okay, and later on I will tell you some more steps, some more things, some regularization things and all, and we'll see if we can improve this error or not, right? Yeah, so I'm winding up today's session, and tomorrow agenda will be what? We'll see the what that is called, mm, unsupervised learning part. We'll solve this problem. Okay, we'll see, first of all we'll see like how we can make this result more better, and second we'll go with unsupervised learning part, and third we will install the library that will be required for what, that will be required for computer vision and all those neural network kinds of thing. Okay, shall I wind up? They solve this problem with different things, whatever different kinds of approach, right? Everyone, yeah, please continue with this problem. Just try to solve this problem with different approach, because there are various approaches are there, and let's see what best possible thing that you are achieving. Okay, so I'm winding up. Thank you everyone, and tomorrow again we will start the session at the tomorrow is Saturday. Well, okay, we will start the session at the same time. I told you like we will start in at 5 or 6, but no, tomorrow we will start the session at same time, means at 2, right? Tomorrow the class will be scheduled at 2 only. Clear? Yeah, 2. Okay, thank you.